I'm teaching Math 53 multivariable calculus, and for today I want to discuss my favorite problem, to find the distance between a plane and a point. So before we're going to start to solve our problem, can you give me an examples of any plane and any point? Any, like, yes, it's up to you. So you have freedom of choice. So we need to choose like two things: plane, a plane, yeah, articles, and a point. Yeah.
The plane is in three-dimensional space, or
yeah, in three-dimensional space. So any plane.
yeah. 3x plus
No, no, it's just simple. Let's sound complicated. For example, like 3x plus y plus z and equals what? What?
pi.
Pi equal pi. Okay. And let's choose a point. So what point do you want to choose?
ln2.
Ellen, no, something simple. Let's do something simple, like let's say 1, 1, 1. Before we're gonna actually, so our question is to find the distance from the point to the plane. Yeah. What should we check first? We should check first if this point is already inside our plane. Why? Because if it's already inside the plane, the distance what? 0. Yeah, 0. But if I'm gonna plug in this point into my plane, we'll get 3 plus 1 plus 1, 5 equals to pi, which doesn't make any sense. So this point doesn't belong to our plane. So we need to find actual distance. What do you think? Like after I have my kind of mathematical objects, what should I do next? How I should approach this problem? Like, any ideas? Yes.
What does it mean to have a distance between a point and a plane?
Okay, so a good question. What does it mean? Like, so in case, what does it mean? Like, I think this is math in this multivariable calculus, and we have a plane and a point. We can graph it. Yes. So let's try to graph like any plane that we have in three-dimensional space, and this is our plane 3x plus y plus z equals to pi. And let's say this is our point A. We have point A with 1, 1, 1. So what is the definition of the distance if you have a plane and a point? Any ideas? Yeah. Okay, someone said the idea of the distance is the shortest path from the point to the plane. And what is the shortest path? Is how it's called in English, like perpendicular? Yes, the distance of this perpendicular. So it's going to be the distance of line segment from A to B, which is perpendicular to our plane.
So you just go straight down?
Yeah, just go straight down. Yeah. Okay, so we have this picture. We want to find like this distance. And what tools of multivariable calculus can we use if we want to find this distance? Any ideas? There is the first one, the most boring one, like that I never remember. Like it's formula. We have a distance formula that you can find in the book. If you give in your plane, you give in your point, you can plug it in and find your distance. But I never remember this formula, so this approach is not the best. Exists another approach. What do you think? Like how we can approach this problem without knowing the actual formula?
Find a line orthogonal to.
Yeah, this is first type of solution. We can just find the line orthogonal to the plane, but I'm going to use another solution. Carson, do you have any ideas?
Optimization.
Is this okay? So first approach, it's like find the line. Yeah. Second approach, write optimization. In other words, write the distance between point and the plane. But there is also a third approach, my favorite one. Any ideas?
To find 3 points on that plane, and then you will become
close. What I want to do, I want to find another point C on my plane. I will find the vector. If I have 2 points, what can I do? I can draw a vector from point C to point A. And then what can I do? How I can find this distance?
You have to
project.
Normal vector.
Yeah. So if we given a plane, for this plane, what does this main coefficients mean? It means for this plane, I have my normal vector n, which is equals to 3, 1, 1. And this normal vector looks like this. This is our normal vector. So my distance is going to be the length of projection of vector AC into the normal vector. So this is our first step. So our first step, we need to find the vector AC. So if you want to solve this problem, we need to do the following thing. So it's 1, 2. So step number 1 is, how should I organize this? So that's step number 1, find the point C. Step number 2, we need to find the vector AC. And for step number 3, we need to find the projection of the vector AC into our normal vector. And then we're going to take the length of our projection AC and we're going to get the actual value of our distance. Do you have any questions about this?
What does number 3 say?
Number 3 is saying that I'm going to find this vector. This vector is going to be my projection of CA into M. This is CA. Okay. Yeah.
What's special about C? How are we finding C?
Basically, C doesn't matter. Why? Because you can take any point on your plane, and for this point, you're going to find the vector. You're going to just project into the normal. So yeah, so let's approach this problem. Let's find for step 1, we want to choose any C. So what C we can choose?
0, 0, pi.
Oh, 0, 0, pi. Perfect. So this is a point. So 0, 0, pi. So step 1 done. Good. For step 2, we want to find the vector AC. So if we have 2 points, how we find the coordinate of our vector? Yeah.
You like subtract stuff.
Yeah, we subtract. So what we subtract? The coordinates of the starting position from the end or opposite? I don't remember also. Like maybe we take C and let's So it's C in this case we have, what is our C?
0, 0, pi.
Ah, 0, 0, pi. Yes, right. So we have 0 minus 1, 0 minus 1, pi minus 1. So in this case our vector AC is just -1, -1, and pi minus 1. Okay, and the third step, we actually need to find the projection of our vector CA. Oh, it's not AC. Okay, doesn't matter. Okay, did some mistakes. I think.
Because
sorry, like
when you take the absolute value, it doesn't mean anything.
Yeah, I will just put minus here and minus, so we'll have minus here. So it's going to be plus 1 minus pi. Okay. But because minus AC is equals to CA, basically. And then I want to find the projection of CA into N. And here it's again a problem. Why? Because I need to remember this formula. So do you know any ways how we can recover this formula without actually memorizing it?
So you draw to line and then.
Yeah, so if you want to remember this formula, let's imagine we have 2 vectors, like x and y. And I want to find projection of vector x onto vector y. So
remember
first,
the definition of cosine.
yeah, is this one definition of cosine? But I like another approach. What is a projection? Projection is like it's the length of your shadow. You can think about projection as a shadow, yes. So basically projection, you will take vector y and you're going to rescale your vector y by some constant. And in this case, you think your projection equal to k times y, where k is some constant. So if you want to find the projection, we want to find the value for k. But you can see that we have like 2 vectors. We have vector x and we have vector ky. And if we have 2 vectors, we can find the third one. And the third one, this is let's say vector z. And what is vector z is equals to? We know that ky plus z equals to x. by using the rule of adding vectors. So from here I can get that my z is equals x minus ky. Yeah. So I got this vector z, and I have my vector y. And what do I know about z and y? That they're perpendicular. So, and if they're perpendicular, it means they're dot product, and I'm going to use these brackets for dot product of y and z is equals to 0. Yeah. So from here I can write this as y equals x minus ky equals to 0. And from here we can see that we can solve for k, and I left like a couple of minutes. So from here we can see that we can solve for k. In the case if we're going to solve for k, we're going to get y x minus k times dot product y with y. So we get that k is equals to yx over y and y. So we know that our constant k is just the dot product of y and x over the dot product of y with itself. Yeah. And so from here what we need to do, we just need to replace our x and y with ca and n. So in this case I will have my x in this case is ca. So I have ca dot product of n over n dot product with itself and times vector n. Yeah, times vector n. Yeah. And we can do all this computation. You will find the value, the actual vector, and your distance is going to be the magnitude of this vector. Yeah, so you can finish this problem at home. But my goal was to show you the idea about how to solve this problem, because by using this approach, then you can find the distance. You can replace this problem with a line and a point, and then you can ask how we can use the same approach to find the distance from the point to the line. And the idea is basically similar, but here I'm going to use not the normal vector, I'm going to use the directional vector, and there is one small trick how we should approach this problem, but this is going to be a whole.
You should probably have a G and a D.
Okay, I know.